Paper 4, long version, Syllogisms with intermediate quantifiers. How Marlo diagrams work.
Visual reasoning in the Marlo diagram. An overview of the diagram. To construct the models of a simple proposition, for example, all numbers ending in 0 are divisible by 2, we must place the subject in the middle of what we will call the propositional model. The predicate must also be placed within the model, but on one of the sides of the model. When we declare that all numbers that finish in 0 are divisible by 2, we are explicitly communicating the association between ending in 0, z, and being divisible by 2, t. That is why in the model we can see that z and t form a type of object zt. All the variables within the same region of a model are necessarily associated and form an unique and distinct type of object in which the contradiction is not possible. We will also write the predicate on the external margin of the model whenever we can conceive that it is possible to have that predicate not associated with the subject of the proposition. Yet in our proposition, the possibility of being divisible by 2 without ending in 0 is left open, and that is why we write a t apart from the z model. Variables outside any model A should be read as associated with not A. Uncertainty is indicated by a question mark. The letter T stands for the possibility T not Z. We have put a question mark in T because, if we eliminate prior knowledge, we cannot know, based only on the proposition, if in fact that type of number exists or not. Now, we add the premise all the numbers ending in 0 are divisible by 5. When different models share the same subject, we can synthesize them into one according to the law of identity. To draw solid conclusions from the model, we must make the correct questions in an orderly manner about all the associations shown in it. First question. How many types of Z are associated with F and T? All or part? Answer. We see in the image that all Z, the only one that appears, is F and T. Second question. Are all types of T necessarily associated with F or only a part of them? Answer. We see that only a part of the types of T is necessarily associated with F, so we can conclude that at least part of T is F. We cannot say that all T is F because there is a possibility, outside Z, of T not being associated to F. Although we cannot say, based solely on the premises, that there is a part of T which is not F. Third question. Can we say that all F is T? Or can we only affirm with certainty that some numbers divisible by 5 are divisible by 2? Answer. We observe the model and we see that only a part of F is necessarily associated with T. The other part of F is outside Z, neither united nor separate from T. If this were the right model, the conclusion would be: all numbers divisible by 5 are divisible by 2. F implies T. We can convert the models from the perspective of any variable. In formal language, subscript x functions as a universal quantifier. We observe that the model of T is divided. A part of T is associated with Z and F. But there is another part of T indeterminated in the premises and that is indicated in the previous models as T question mark. Each region of the models shows one of the possible combinations between two variables. The meaning of the blanks within a model depends on the context. Basic structure of elementary propositions in the Marlo diagram. Every simple proposition may be reduced to the expression of a relation between two ideas. The two ideas are represented by the two terms, subject and predicate. These terms may be either both of them individual, or one of them individual and the other collective, or both of them collective. Bentham, 1827. The figure shows with examples the logical structure of the four elementary propositions. The first decision we must make when representing a proposition is whether to divide the model of the term which functions as the subject. In particular propositions, the model must be divided, but not in universal propositions. In the proposition being even number is equivalent to being divisible by 2, the subject is universal because we cannot conceive that a part of the even numbers is not associated with being divisible by 2. However, in the proposition some prime numbers end in 1. The subject is particular because the logical structure of the proposition still allows us to suppose that there may be prime numbers that do not end in 1. The second decision we must make to represent sentences in the diagram is whether or not to write the predicate outside the model of the subject, that is, outside the circle. In the proposition "only among mammals are there any humans," the predicate is universal because the structure of the proposition eliminates, in theory, the possibility that there are humans that are not mammals. However, in the proposition some prime numbers end in 1, the predicate is particular because we can still assume that there are numbers that end in 1 without being prime numbers. In the propositions with the particular predicate, the predicate is represented outside the model. In propositions with the universal predicate, that predicate only appears within the model. We should note that the fact that the propositions are affirmative or negative does not affect the basic structure. We can also observe in the image that terms such as non-human, non-drinking and non-carnivorous can act as subjects of the propositional models. Complex models. The figure shows models of increasing complexity about schizophrenia. Each particular premise requires opening a new extension in the models in order to temporarily separate different types of things which, however, could eventually become the same thing. Note that what is represented in each region of the diagram are abstract entities, types of objects, but not concrete entities. The main idea is that each region of a propositional model contains a brick or element with which it is possible to create different types of objects by combining them. Logical connectives in the Marlo diagram. A simple proposition informs what kind of association has been established between two concepts. Therefore, we can classify logical connectives and Aristotelian propositions with the same elementary structure. We should only bear in mind that cognitive systems are capable of distinguishing two kinds of propositions: theoretical statements outside space and time, ongoing facts here and now. Generalizations eliminate network paths. Marlo diagrams, tree diagrams and truth tables show us the same information. That is, what combinations of variables have been removed from the mental space. However, the tree diagrams and the Marlo diagram can also show the degree of activation of the variables. In the center of the image we can observe the tree diagram of a biconditional proposition. We observe from the perspective of criterion that starting from A we can only arrive at B, and that starting from not A we can only reach not B. For the perspective of criterion B we observe that, starting from B, it is only possible to reach A, and that starting from not B it is only possible to reach not A. The same information communicates to us each one of the propositional models of the Marlo diagram. Starting from any one of the models, we could reconstruct the entire network through the processes of conversion and transformation of models. The combinations of variables eliminated in the diagrams appear in the truth tables with the value 0. At this moment we observe diagrams and networks without activation. They are theoretical models without real influence in the cognitive system at this moment. It is evident that the law of excluded middle is only now fulfilled at a theoretical level. When a stimulus activates the network, the elimination of a possibility determines the propagation of energy through its alternative. The propagation of activation through reinforced associations is the basis of the inference in the Marlo diagram. Activation is propagated in all directions in the theoretical system of beliefs and expectations. When a path is not impossible, there is no necessarily alternative, and the activation of the network only generates probable inferences. Inferences in the Marlo diagram. Inferences by synthesis. The models of identical variables attract each other. Universal synthesis. From two universal models, a universal model is followed. Adrenaline is a bioregulator. Adrenaline is a catecholamine. Therefore, at least part of the catecholamines are bioregulators and vice versa. Particular synthesis. From a particular model and a universal one, a particular model. All mammals are vertebrates. Only a mammal can be a horse. It is clear that, at least in theory, there are vertebrates that are horses. Since we see that the only H that is in the model is associated with V, we can say that all horses are vertebrates. Probable synthesis. From two particular models nothing is necessarily followed. In the context of my family. If you are a hunter, you are my brother. If you are a fisherman, you are my brother. Maybe I have brothers who are neither hunters nor fishermen. The premises do not say anything about it. The only conclusion that necessarily follows from the premises about my family is that it is probable and more than possible that someone is a hunter and a fisherman at the same time. Remember that the sides of a complex model can be combined by generating types of probable objects. Inferences by exclusion. Law of non-contradiction. Universal exclusion. Minerals are electrical conductors. Coal is not an electrical conductor. It is impossible to associate the models of M and C. Then neither minerals can be any kind of coal, nor can coal be any kind of mineral. Partial exclusion. Some Britons are not English. All Londoners are English. Therefore it is impossible for some Britons to be Londoners. What do we know about the other possible Britons? Maybe they are all Londoners, but the premises do not affirm or deny it. Maybe all Londoners are Britons. We can only say that some Britons are not Londoners. Null exclusion. Some primates do not read Shakespeare. Some humans read Shakespeare. We can only say that certain part of primates cannot be associated with certain part of humans. Or vice versa. Maybe all primates are humans. Maybe all humans are primates. In this case we cannot say anything with certainty because there is no impossible. Some conclusions. The Marlo diagram returns to the idea of quantifying the predicate that was already followed by authors like Bentham, Hamilton and De Morgan, and, at the same time, offers a new point of view on inference based on two old principles of philosophy and psychology: identity and not contradiction, synthesis and analysis. The following tables show the new classification of the syllogisms that is offered by the Marlo diagram. Blue means conclusion by synthesis, red means conclusion by repulsion. Yellow means uncertainty.
In the videos of Article 21 we show the good results obtained with the Marlo diagram in the classroom. The development of the Marlo diagrams has generated the Marlo networks of expectations. In the videos of Documents 5 and 32 we explain the theoretical foundations of these networks, as well as their practical applications in the classroom to work with heterogeneous reasoning.